Hello, everybody. I don't know where you're sitting or standing. Maybe you're on the subway, maybe you're at home, maybe you're in your kitchen, but wherever you're listening to this, hopefully today you're going to do some thinking because we're going to talk about thinking. Thinking is one of those things we simply take for granted. We rarely ask ourselves why we think the way we do. We could simply say that we don't think much about thinking, and yet psychologists have spent quite a lot of time and effort to try and understand the underlying process and processes, I should say, of thinking. Let's start with a definition here. The term psychologists usually use when they study thinking is cognition, and cognition is defined as mental processes and activities, or mental activities and processes, and again, they're associated with thinking, knowing, remembering, communicating this information. Also in there are our ability to make judgments, our reasoning skills, taking new information and organizing it and processing it into what we call knowledge. And it affects and is impacted by so many other areas of what it means to be human. Our attention span or attention ability, how much we concentrate. Emotions certainly affect thinking, as we'll see. The notion of consciousness, how we perceive the world, how we learn, our ability to remember, and processing of memory. Language is very important for thinking. We think in a language. It's the software of thinking. And again, our mental health processes, you certainly perhaps have the experience where you're depressed or you're anxious. We don't tend to think clearly. And to put the cherry on the thinking ice cream slices here, or ice cream mounds here, our social interactions with other people, with media, tend also to affect our thinking processes. We can't get away from this slide without the conclusion that thinking is an extremely complicated process. And I want to try for the next half an hour, 45 minutes, to walk through some of the aspects of thinking. First of all, we want to break thinking down. And the first question we want to ask is, why are concepts considered the building blocks of thinking? Psychologists have made this conclusion. Think about it. How do you think without having concepts to think about? Just like if you were going to build something out of Lego, in order to build it, you have to have the blocks that go into building whatever it is you're building, an airplane, a house, a Lamborghini. So concepts, the concepts we have, and I know that's a fuzzy term, but the concepts we have allow us to think. Now, a quick conclusion. The more concepts you have, the more nuanced and variable and complicated the concepts you have, it goes to say that the more deep and wide and high and low your thinking is going to be able to be. This is one of the reasons why reading is so important to thinking clearly. Because the more you read, the more experience you have in the world, the more your thinking is going to be informed by that reading, that learning, those experiences. And the second question we want to take up here is, what are some of the problems? What are some of the problem-solving strategies? And then what are some of the obstacles that come in these problem-solving strategies? It is not that easy to think clearly. So, moving right along here, let's take up this idea of concepts. Let's define it first. I said it's fuzzy, but a concept is simply a mental grouping in our brains, in our minds, of something that goes together. Similar objects, similar events, similar ideas, similar people. Concepts are the way our brain organizes the world at its very, very basic level. And it certainly is the underlying problem that we face when we have a concept in which we group things together that don't necessarily belong together. And So for instance, sexism and racism and anyism would simply be a conceptual way in which we group, but if we step back from that, we have to admit that sometimes our conceptual grouping is problematic. So a concept, this grouping, can be represented and communicated by an image. I can have a picture in my mind that groups by a word, which is just a symbolic representation of an image. For instance, if I said a chair, or a party, or democracy, or a TV show. So concepts can be expressed and are expressed both imagistically and linguistically in terms of words. Now, how do we form and learn concepts? Well, we might think that we form concepts by defining something. So for instance, we define a triangle as an object with 3 sides. But is this how we actually form concepts? What I'm trying to get at here is, do we get concepts first and then come up with definitions? Or do we form a concept from a definition? The reality is we often form concepts by developing prototypes based upon our experience. A mental image in our mind is the best idea of a concept. So if we draw a triangle, what does the prototype of your triangle look like? Again, there are all kinds of different triangles. There are short, squat ones. There are ones in which one side is perpendicular, one side is horizontal. There are all kinds of images that we have of a triangle. And each of us, when I say the word triangle, almost immediately responds with some prototypical image of what a triangle is like. And the reality is all of our prototypes, or all of our concepts of triangles, are not exactly the same. And yet, they all share similar properties, and indeed, in the example of a triangle, they all, regardless of color and the way they're positioned, they all have 3 sides. That is a definition of a triangle, but our prototypes of them may be quite different. So let's take another example. We could come up with a definition of a chair, and clearly, though, when I say the word chair, when you read the word chair on the screen in front of you, you thought of something. Now, a prototype of a chair isn't a particular chair, but it's this general image of a chair I have. And as we think of chairs, we can think of all kinds of different types. But the reality is if looking at these 5 images in front of you, would all of them qualify as a chair? Now, our definition of a chair may be something that we sit on, but is a swing a chair? Is a chest that little boy is sitting on the top of your screen a chair? Is a fence post a chair? In fact, is a stool a chair? The reason I'm begging this question is because we have a prototype of the chair, and we expand that prototype a certain way, but once we get beyond that image, that prototype, we have to say that a chair isn't necessarily anything you sit on, okay? Because I can sit on a table. Is a table a chair? You know, I could sit on my brother. Is my brother a chair? So sometimes definitions and prototypes don't align exactly and particularly well. Look at this series of photos going on the screen below you. I don't know if you noticed that, but let's take one of those images. Now, if I was to ask you what percentage Asian is that picture in a blended Caucasian Asian face? Or let's try this again. Look at that picture. And again, we could ask the question, what was the percentage Caucasian in that second blended face. It's a human thinking imperative for us to categorize. In fact, one of the things that thinking allows us to do is to come up with these concepts or come up with these prototypes. And by virtue of doing that, it's necessary that we come up with categories, because categories allow us, again, to divide, to make separations between concepts. Now, we would certainly say that some concepts, like for instance my concept of person, is a little bit different than my concept of man and my concept of woman. Now, both the men and women are persons. When I say the word person, did you think of a man or a woman? So concepts and certainly prototypes overlap, but we tend to mold our memories and perceptions of the world as we go through and experience the world on these pre-existing categories and concepts and prototypes that we have. In other words, when we experience the world through our brain, we tend to use already developed prototypes and concepts to put the new information, to store the new information. It's almost like we have files of men, of women, and we meet a new man, and again, we put that man into the category of prototype. Now, subtly, we may change our prototypes over time as our experience of one or the other concept grows, but we're always categorizing. We're always trying to categorize. And when we have a group of faces, we're going to categorize that, even if it's difficult. We're going to come up with a category. And so very often, this is how our prototypes fail us, because they don't always allow for everything that fits in the prototype. And again, if we come back to our example of a stool and a chair, is a stool a chair? Well, there's a good reason why we have two different words for chair and stool. And we could spend the rest of today arguing about, is a stool a kind of a chair? Probably our category of chair is bigger than stool, or does a stool differ enough as a word or as a prototype to distinguish it from chair? And perhaps both those are subcategories of things we sit on. And again, if we have a category of things we sit on, we could include a chest, we could include a fence post, we could include a table, we could include grass, and so on and so forth. So prototypes fail us when our examples stretch our definitions. They also fail us when the boundaries between our prototypes or our concepts are fuzzy. And again, if I gave you a series of pictures, like images of blue-green colors or computer blended faces as you watched that man between Asian and Caucasian. When things start to get fuzzy, the idea of Asian, someone who's Asian or Asian American, since we're in the United States, someone who is Caucasian, we have separate prototypes for those, but when we start blending them, or when we start blurring the edges of those categories, our prototypes tend to fail us somewhat. So if I gave you a bunch of pictures of men, and I said, okay, I want you to pick out who is Asian, who is Latino, who is Caucasian, who is African American, and so on and so forth. Well, again, and we started to blend those categories using computer-enhanced images. What starts to happen is our prototype, which is pretty accurate and exact, doesn't work anymore as it gets fuzzier and fuzzier and fuzzier between them. Finally, prototypes fail us when our examples in the world, for instance, contradict our prototypes. So we've all heard the fact, and I certainly remember as a kid being extremely disoriented when I learned that a whale was a mammal, like a tiger or a human, because clearly when I look at things that swim in the ocean, my prototype would be fish, and whales swim in the ocean, and yet they're not fish. Or again, a less obvious example is a penguin being a bird. My prototype of a bird is something that flies, and clearly penguins don't fly. So there are plenty of counterintuitive examples that we will face in life, which don't necessarily fit the prototypes, and again, that we've developed. Our prototypes clearly are going to be a function of our experience and our learning and our knowledge and our exposure. If we're wise, we're constantly adjusting our prototypes to deal with new information that seems to contradict my old prototype. And indeed, if I have a stereotype of some group and I'm faced with examples of people that don't fit that stereotype, one way to do it would be to ignore the examples, and that's what we so often do. But a better way would be to slowly or quickly, but I think it happens slowly to us, is slowly adjust my prototype to accommodate all of the examples, to make it more accurate. Because after all, if we want to think clearly, we want our concepts and our prototypes to be as accurate as possible. Now, we began earlier by talking about problem solving as one of the things we wanted to talk about. And indeed, one of the great capacities we have as human beings, particularly our cognitive abilities, is to face problems. And all of us, you and I, we face problems every day. And so problem solving certainly is a very important subset of thinking. And again, if we define this, it's the type of thinking in which there's a complex question, or there's something we have to figure out, and something we have to resolve in the best way we possibly can. Now, you and I are faced with problems, big and small, every day, every month, every year. Some of them, of course, we can quote-unquote solve or figure out or resolve. Some of them are lifelong, can I say, struggles to try and understand, to try and process problems. But clearly, if we want to solve problems, we want to come up with strategies to be able to do that. Now, one of the things that we do when we face a problem is we engage in what psychologists call trial and error problem solving. It simply is the process we go through when we try stuff out. And if it doesn't, we try something out. If it doesn't work, we try something else. If it doesn't work, we try something else. In other words, we keep trying different things until we get to something that seems to work. Now, it's certainly useful. Edison discovered the light bulb down the road from me in West Orange, New Jersey, by trying out hundreds and hundreds and hundreds of filaments inside a light bulb till he finally hit on one that worked. So it's certainly useful, but as Edison discovered, it takes quite a lot of time sometimes, and we don't have all the time in the world. Now, if you're inventing a light bulb, it's a pretty important invention. It may be worth years of engaging in try and error. But it tends to fail when there's a clear solution out there that we don't try. None of us has full and complete knowledge of all the possible things we could do. We're not omniscient. And so there are plenty of times in life where trial and error is not going to work because simply we don't try the thing that will work for whatever reason. A second strategy that we often use is what psychologists refer to as algorithms. An algorithm, quite frankly, is just a step-by-step strategy for solving a problem that will methodically lead us to the solution. We all remember algebra. We all remember formulas in chemistry or in biology, formulas are an example of an algorithm. If you're watching Netflix and you just finished watching a show or a movie, Netflix will often suggest shows that you might like. And how does Netflix know that? Well, Netflix isn't reading your mind. Netflix has just come up with an algorithm that if people watch this show and that show and this third show, then chances are this fourth show will be one that they like. Algorithms can work, but I have to say that almost never have I ever gotten a suggestion from Netflix about a show I would like that I said to myself, hey, I think I'll like that. In fact, usually my response is, what? What kind of lousy algorithm does Netflix have that it would suggest that show to me? I'm not at all interested in that. So algorithms are just these step-by-step strategies, and indeed we come up with these. If I do this and I try that. So for instance, if you have misplaced your phone, you don't know where your phone is, or you don't know where your car keys are, how do you go about trying to find your phone? Now, some people just start freaking out and just start looking all over the place and screaming, and but an algorithm would be to sit down and think clearly. Okay, where have I been in the last half an hour? And to use a step-by-step process of going to where I was. Where did I remember being just 5 minutes ago and then 10 minutes ago? Did I walk out to my car? What clothing was I wearing when I came home? And so on and so forth. And so that would just be an example of an algorithm. Not a very exact one, but it tends to work most of the time. A heuristic is a third strategy at coming up with a solution. Heuristics are quick, very short-term strategies. We don't have to think too much. There are principles we use which generate a solution quickly. But we use heuristics to save time, to save energy, and so it's a shortcut, if you will. But as all of us have discovered who refuse to consult a map or use our navigation devices, shortcuts don't necessarily always work. A shortcut that's wrong doesn't get us where we're going. Some people like shortcuts just because they're shorter. Well, a shortcut that's shorter but doesn't get you where you're going is not one that works. So trial and error, algorithms, and heuristics are all things that we use in order to solve the problems that come before us. Insight is a fourth one. Insight is very hard to explain. Psychologists have tried to figure out what insight is all about, but it remains somewhat of a mystery. It's just this sudden kind of aha moment, this sudden light bulb moment over our head in which our brain figures stuff out. There's a solution there, and once we have an insight, it's kind of interesting because once we have an insight, it almost seems like it should have been self-evident from the very beginning. But it is this, and I put the term mysterious in quotes, but it's this mysterious kind of processing that our brain figures something out almost unconsciously and puts the information together and delivers to us kind of like the solution. Now, let's come up with an example. You're in a store and you think, okay, I need to buy some apple juice. How am I going to come up with this? Now, trial and error, of course, would just be to wander around looking for apple juice. And, that's how sometimes people do it. But most of us know when we go to a store that there's an organization to the store. And even though we might not have been in this store, let's say we're in A&P and we normally shop at ShopRite or at Wegmans or at Whole Foods or something like that. Trial and error, unless you have a lot of time on your hands and you're just wasting your time, doesn't seem to be a very good way to solve the problem. An algorithm would be to create some path. So you might just walk up and down an aisle systematically. Aisle 1, top to bottom, mile 2, top to bottom, mile 3, and so on and so forth. Now that would be an algorithm, but that would take almost as much time as trial and error because pretty much you are going through the whole store. You're doing it more systematically than trial and error, but you would certainly find the apple juice, but it may not be the best thing to do. A heuristic would be, of course, to check only the related aisles. And again, most of us, we use a heuristic. We know that apple juice tends to be with other juices. So we will walk maybe down the main aisle, in which all of the aisles are come off of, and we'll slowly read the signs, the helpful signs, and we'll look for one that says juices, and we'll walk down that aisle. Now there may be two, because as I've noticed, different stores organize fluids or beverages differently. I'm always looking for green tea. Now, is that with the tea? Is it with the soda? Is it with the miscellaneous beverages, which include, I don't know, energy drinks and tea and juice and so on and so forth? But at the most, we probably have two aisles, and we're going to find the apple juice faster than if we wander around, if we come up with some, algorithm. It's simply an example of doing that. Now, let's compare trial and error versus algorithms here. So let's say that I give you a bunch of letters here, and you need to figure out what these letters put together spell in terms of a word. Now, trial and error, you would just randomly, as you eyeball it, look at the letters and try and organize them, and you're hoping that there's some recognition pattern in your mind. But it's going to take a long time, and these are a lot of letters. An algorithm, again, may take a little less long, but you may want to say, well, I'm going to take one letter, C, and I'm going to put that first, and then I'm going to organize all the other letters in every possible way. But clearly, with all this amount of letters, your algorithm, which could work quickly if you got lucky, if you put the letter P first, but that's going to take you a lot of time. Again, using the trial and error technique, I didn't count these. There are almost 750,000, a little over 750,000 different ways to combine those letters. And again, that's a lot of time. The algorithm way is going to cut down on the process because there's a system to it which you're going to try. And since there's only so many different letters, at least you're going to be organized in your way of going about it. A heuristic approach here would be to, we know that if you have a bunch of letters and there's a Y in there, I don't know if you know this, Y's almost always come at the end of a word. Unless it starts with a Y, most Y's, there are exceptions to that, say physiological or something like that. But if you think of the word sociology and theology and gerontology, Y's almost always come at the end. So I might start with the Y. And Y's are relatively rare letters, as opposed to vowels or as opposed to S's and so on and so forth. So I might want to start with the Y as a key letter. Again, if you speak English, you know that the ch sound, ch, I might put together, or the sp sound, the sp, those often go together. So I want to put those in combination and almost treat them as one letters. And again, we know that vowels are rarer than consonants. So one of the things I'm going to avoid is putting the vowels together. So if I have two O's, with apologies to the word cool and school and whatnot, rarely do two vowels, and particularly two similar vowels, two exact the same vowels, go together. And again, as I begin with this process, my heuristic, again, I may be still doing some trial and error, still using these rules, but the heuristics, the shortcuts, as long as they're correct. Now I can use a heuristic. Maybe I have the heuristic that words that have a Y in them, the Y is always the second letter in the word. Well, that's a heuristic, but unfortunately, it's an incorrect heuristic in just about every single example. So, but if I have correct heuristics, again, I can eventually figure this out, and I eventually come to, that great word, psychology. Yes, we have discovered the correct word here. I'm talking British to sound very, very intelligent, and it is psychology. Now, trial and error, we're going to leave that, but algorithms are important. As we said, an algorithm has the advantage of being at least somewhat thorough, but algorithms clearly can be used in almost a heuristic kind of way. There are algorithms, for instance, Netflix algorithms that they come up with to present me movies. Again, it's systematic, but it can't. Obviously, my screen isn't big enough for Netflix to present every possible movie I may like. And so that would be a thorough way. And so in some ways, algorithms can also include some heuristic shortcuts. Let's say we had this problem. A father and son are age 40 and 10. And here's the question for you. When will the son be half the father's age? Now, we could try and do that by trial and error. But we could just use a simple algebraic algorithm, and it's simply x equals 1/2 times x plus 30. And you'll just have to take my word for it that that's the algorithm to figure this out. And again, once we do the math here, x equals 30. And so what we have here is the solution. The son will have to be 30, and again, the father will be 60. So what we want to point out is that some of our algorithms use heuristic aspects to them. We can't, and of course some of our trial and error attempts have algorithmic aspects to them. So while we're talking about these for the purposes of our discussion here, they overlap quite a lot, and they're not exactly always clearly distinct. Now, let's just give you one more example here. Let's say we have this problem. We have 100 feet. We have 101 foot lengths of fence, and we have to construct a rectangle. And a rectangle is defined as something with 4 sides. And the problem here is that we want to enclose the maximum amount of space or acreage within this 100 feet of fence. Now, the trial and error is that we come up with a lot of different rectangles and again measure the area within the rectangle and try and figure it out that way. The algorithmic approach is, and I would never do this is way too complicated, but we would come up with a definition, in areas width times length, and we'd go ahead and go through all of this, and I'm not even going to read it to you. You can pause the video and read it on your own, and I promise you it's correct. That seems like a lot of work. On the other hand, a heuristic would be something that some of us may already know, in that perhaps we learned by experience or in some book or some class that a square always encloses the most area, and so it would be easy. We would simply say that we have 100 feet, and simply it's 25 by 25 by 25 by 25. Now, moving ahead, let's talk a little bit about insight, because remember we mentioned that insight refers to this aha moment, to this moment when the light bulb goes on over my head. I'm in the dark, and all of a sudden, as the song goes, I saw the light. And again, sometimes when that happens, we laugh, or because we get it. Like a joke, as soon as we get a joke, we laugh because all of a sudden it makes sense, and that's why some of us like jokes. So insight is this sudden realization, this leap forward into thinking. And as I mentioned, psychiatrists and psychologists have studied this. And here's a classic line from, or a classic study that has used in terms of insight research. And the question would be, what fourth word could you come up with that you could join with the following three words as a compound word to make sense of them? So our three words here are pine, crab, and sauce. So now the challenge here is to come up with a fourth word that I could combine with each of those three words to make sense out of them. Now, try and think about that for a little bit. Now we could use all kinds of, we could use trial and error. There's a lot of words in the English language. We could use some kind of algorithm where we start with A and we try every word we know with A. We could come up with some heuristic. None of those really would apply in this situation. None of us have a rule about this. And so psychologists say this is where insight comes in. It's not trial and error. It's not an algorithm. It's not a heuristic. It's just simply insight. And ladies and gentlemen, if you haven't gotten it yet, the answer would be apple. Again, pineapple, crabapple, applesauce. Those would be the three words here. Let me give you three more, just to see if you can do this. Let's take the words, and I didn't put them in my PowerPoint here. Bump, B-U-M-P, step, S-T-E-P, and egg, E-G-G. Bump, step, and egg. Again, the answer would be, anyone get it? Raise your hand. I can't see your hands. Sorry. The answer would be goose. Again, goose bump, goose step. This is what Hitler's soldiers did. And goose egg. Third example, since I'm wasting your time, the three words back, B-A-C-K, clip, C-L-I-P, and wall, W-A-L-L, back, clip, and wall. And the answer would be, I see that hand in the first row by the front of the computer, paper. So obviously paper back, paper clip, and wallpaper. Now, studying insight is quite interesting. Although we don't know why this happens, we certainly know that certain brain areas are particularly functional when insight happens. We certainly know that the frontal lobe lights up, and there's a burst of activity in the temporal lobe, which is in the middle of your head, on the right temporal lobe, not the left. And as psychologists study this, again, if certain brain areas are lighting up, particularly the frontal and the right temporal lobe, then it certainly means that insights, there's something about the combination of those two parts of the brain to give us, can we say, clues into how and why insights work. Now, there are plenty of obstacles that you and I face when it comes to problem solving, and clearly I want to talk about some of these. One is what we refer to as confirmation bias, and we'll give you some examples about that. Another one is what we call mental set, or it's also been called fixation. It's the difficulty we have in thinking a different way than we normally think. And clearly, as we've already mentioned, sometimes our heuristics are wrong. Speed is a good thing if you get it right, but as I used to interact with my son when he was in 6th and 7th grade, he'd come home and he'd he had to do all of his homework before he could play any video games. So literally, he'd get all his homework done in 10 minutes and playing video games. So one day I said, I checked his homework, and of course, 90% of them were wrong. And I said to him, Brandon, your homework is all wrong. He goes, oh, Dad, homework, you're just supposed to do homework. You're not necessarily supposed to get it right. So his theory was speed, and admittedly, for his purposes, which were to get to video games as soon as possible, it worked for him. But heuristics can be a problem. Let's talk about confirmation bias. Confirmation bias basically refers to our tendency to search out data and information which basically confirms how we already think. And that's the first thing. The second thing is I ignore any evidence which would challenge my current way of thinking. So all of us have this natural tendency. We have this problematic trust with, hey, I'm right. And we begin with that because that's just how we are. And fact C confirms my theory, so I'm going to look for fact C-like evidence, and A, B, and D I'm just going to pretty much ignore. As opposed to, if I want to think clearly, or if I want to think scientifically, I would say it a different way. If I'm right, then fact D will either prove or disprove my theory, and so therefore I must search for fact D. Confirmation bias is simply the bias that all of us have to have our present views confirmed by the evidence. Of course, the evidence is selective. I latch onto evidence that confirms my view and ignore evidence that doesn't. Here's something called Peter Watson's selection test. Gives a bunch of people the sequence of numbers 2, 4, 6. Okay, and he asked them to guess what his rule is, and asked him whether other certain numbers are going to fit this rule. Okay, now the students came up with all kinds of theories, as you might. And that's not the problem, but it's the strategy of coming up with the theory. So the most obvious thing here to explain this numbers is 2, 4, 6. Well, this what explains this sequence is, well, these are even numbers. Okay. Now, what other numbers would you need to ask him about to test rather than confirm your theory? Clearly, if I asked him about 8, that would just confirm my theory. But would I ask him about 0? Would I ask him about 7? In other words, the idea here is I look at this, I see 2, 4, 6, I come up with a quick theory, and then essentially I look for information that's going to confirm my theory, and I ask about numbers like 8. Instead of looking for a number which would disconfirm this theory. What Watson was looking for is not actually people's ability to solve this, but the strategy they went about to confirm or disconfirm the theory, and that is the essence of confirmation bias. Let's give another example of this. Okay, so let's say that you have heard. Okay, I want you to test this. Everyone who drinks alcohol at this party is at least 21 years of age. Okay, so that's the statement, or that's the fact. And you meet 4 people at this party. One is holding a beer. One is holding a cola. One is definitely age 25, and one is age 18. Okay, now if you could ask just 2 of these people a question or two, which 2 would you ask to help you find out whether your hypothesis is true? Okay, now again, think about this. How do we do this? And we might think, well, I don't know what you're thinking. The correct answer, of course, is I would talk to the person holding a beer. to make sure that they're at least 21. And I would talk to the person that's age 18 to make sure they're not holding a beer. And voila, I don't have to worry about the other two. That's the way I would do it. But clearly, confirmation bias is one of those things that might get in the way of this and get in the way of solving it. Here's another example, okay? You're given some cards. On one side they have a letter, and on the other side they have a number, okay? Now, the fact I'm trying to prove or disprove is if a card has a vowel on one side, then it has an odd number on the other side, okay? That's all. Vowel on one side, then an odd number on the other side. Now, if you were to test to prove or disprove your theory and not engage in confirmation bias, which two cards would you turn over to find out if the claim was true? Now, flipping over A could confirm or disprove the claim. Flipping over D tells us nothing because the claim had said nothing about consonants at all. But flipping over 6 is probably crucial, and it's often missed by people because even numbers are not mentioned in this claim. If there's a vowel on the other side, then the claim is not true because flipping it back over, there's not an odd number. And indeed, flipping over the 7 is a chance to confirm the claim, but it can't be used to disconfirm the claim. So really, the two cards would be the D and the 7. Again, if you want to pause this and think about that a little bit, rarely do people come up with the 6. It's the one that's least likely to come up, and yet that's the most important thing. Let's give one other example. How do we avoid confirmation bias in research? Now, if we believe that overeating candy is the main cause of ADHD, okay, let's just say we believe that. Okay, so what types of people would I need to look for to test my theory? Okay, now I would definitely want to test kids that eat a lot of sugar, but I'd also want to test kids that do not eat candy. Because if I test kids that do not eat candy and a bunch of them have ADHD, then clearly that calls into question my theory. And thirdly, I want to test kids that have ADHD, but those that do not have ADHD. The reality here is in real life, confirmation bias tends to short circuit the process to getting to not just a confirmation but a disconfirmation of my claim or my bias. But science has to look at a claim not just to confirm it, but also to look for evidence that would disconfirm it. Mental set is another example, and fixation a third example of problems that get in the way of problem solving. So mental set would be simply defined as the tendency to approach a problem with some kind of mindset, some kind of perspective or view, and we all have these. Fixation would be a variation on this theme, just a tendency to get stuck in one way of thinking or thinking about something from one perspective. Fixation would be the opposite of creativity. Now here's the thing about both mental set and fixation. Why do we have these? Because we have experience in life trying something out this way or thinking about it that way, and for better or for worse, it's worked for us. I remember reading something, and it was pretty much asking the question. So if you had a really, let's say you had some kind of sickness or disease or physical problem, do you want to go to a doctor with a lot of experience, or do you want to go to a doctor that just got out of medical school? Now, most people will say, I want to go to the doctor with a lot of experience. And but that may not be the right answer. The problem with a doctor with a lot of experience is this doctor has seen so many examples of this, he or she is likely to go quickly to a mental set. In other words, oh yeah, I've seen this before, it's this. Whereas the doctor that doesn't have all that experience may be willing to listen to and pay attention to all of the aspects of the situation in front of them without going to a mental set. Experience can be a good thing, but the downside to experience is that we can assume that similar events as you face them, as I face them in the future, are going to be like past events. When indeed life is full of things that seem similar, but lo and behold, prove to be very, very different. So mental set and fixation is something that everybody is going to experience. Now, if I was to say, okay, look at these letters, O, T, T, F. What would come next? What would come next in terms of the next two letters? Think about that. Well, okay. I see all of you got it already. The next two letters would be S and S, right? You're like, what? So these would be the first letters in numbers. 1, O, 2, T, 3, T, 4, F, 5, F, S, 6, S, 7. Okay? You got that? Okay. How about this one? What would be the next two letters here? We have J, F, M, A, M. Yep, you got it. The next two letters would be J and J. So January, February, March, April, May, June, July. JJ. Now, so far so good. How about this one? S, M, T, N, U, what? Now, I don't want to leave too much gaps on this video clip here. The next ones would be O, V, P, W, X, Q, R. And you're like, what? This would be a different pattern, right? It would simply be alternating alphabet. So if you look at every other letter, S, T, U, V, W, X, Y, Z, and then M, N, O, P, and so on and so forth. Now, why? And most people take a long, long time, if ever, to try and figure that out. What's going on here? Well, with the first two examples, what I did is I set up a mental set in your mind using numbers and then months. And again, we could probably think of days and any number of other kind of set. But all of a sudden now, you have to think very, very differently. Instead of the first letter that comes after some sequence that we're familiar with, you have to think in an alternate way. How about this one? W-I-N-I-T-S. What would that be? Again, now I've given you two mental sets. And this last one, again, most of us could spend quite a lot of time here. The next one should be S. What is that? Well, if you look at the sentence that began this slide, what is next in these sequences? It's the first letter of that sentence. Now, mental set is just clearly setting you up to think a particular way. You're primed, if you will. Your brain is primed to think along a certain kind of pattern or sequence, and again, we're often primed. One of the ways we're going to be primed in thinking about everything is on the basis of our past experiences. Our full-orbed experiences with people and with life prime us to think a particular way. I am primed to see the world on the basis of my experience as a male. Okay? Now, if you're a female, you're primed to see the world on the basis of your experience as a female. It doesn't mean that I'm right and you're wrong, or you're wrong and that I'm right. We just have to admit that experience primes me to see the world in the way that I've experienced it. So mental set so often gets in the way of solving a problem because I can't get out of the mental set. I shouldn't put it that way. It's difficult for me to get out of my mental set, and clearly often gets in the way of me being able to solve a problem. Fixation again would just be when we think in a particular way, and it's hard for us to get ourselves out of this kind of trough of thinking. And you've probably all seen this particular problem. How do you arrange these 6 matches to form 4 perfectly equilateral triangles? And again, when people struggle with this, the fixation that they're fixing on is that when we look at matches, we tend to think in 2 dimensions, not 3 dimensions. And so this mental set, or this fixation, is just basically we're trying to arrange these flatly on the table or on the desk in front of me instead of thinking 3-dimensional. 3-dimensional thinking, again, would get me out of my mental set or out of my fixation and allow me to solve this problem. So these kind of things get in the way. Let's just give some other examples since I'm wasting your time. Use 4 straight lines to connect the 9 dots. Okay? And again, this is difficult because one of the things most people tend to do is they start drawing and limit themselves in terms of their lines to only as far as the dots go. But the solution to this, again, is to go outside an extra space with a line and to be able to do that. Literally, you got to think outside this box. We tend to see those 9 squares and our lines as having to stay within those 9 squares. But in order to solve this, I have to go along. And again, how about 3 straight lines to connect these dots? Well, some people try, and just like the last one, the mental set or the fixation is, my lines have to stay, again, within the parameter of what looks to me like this 9 windowed box. Clearly, I can do it, but thinking beyond the pale.